So, the first speaker. Going into the building sector as a computer professional with a diploma in social education may sound unusual at first. But in sustainable building with fast-growing, renewable materials, there are rather few technicals than more social problems with regard to the Whisper application. He helped set up the further education department at the North German Center for Sustainable Buildings. As a chairman of the think tank Bauamt, he advocates efficiency, sufficiency, resilience, health, and radical minimization of embodied carbon. Michael, are you listening? Us? Welcome.
Yes, hello.
The stage is yours. Thank you.
So I hope you can see my presentation. Thank you for choosing the straw color for the conference theme. I like it. Thank you. So now my presentation isn't moving. Wait a sec. So there we go. Yeah, straw is a thermal insulation. This is the topic of today, and I will split this into two parts. I will obviously, as you can see behind me, and later on, I hope we have a lively discussion about it. And yeah, let's start. So this is basically what most people think when I talk about straw in construction. They think about some non-permanent, high maintenance things, but this is not exactly what I'm talking about. This is somewhat true because this building material is actually pretty old. This is what our civilization began actually over the world, basically everywhere. So actually, I'm talking about these kinds of buildings, missing middle, missing mid-rise, like higher buildings, more compact, healthy buildings, affordable, and high performance too, so low energy demand and low impact, so circular, fully reusable. And if this house would serve no purpose anymore, it could be composted. That's the goal. So yeah, I'm working for the NZNB. It's an abbreviation because we have such a long name. This is the Norddeutsches Zentrum für nachhaltiges Bauen, the North German Center for Sustainable Construction. And it is still the highest directly plastered strawware building in Europe. And we are working hard to make that not anymore. There should be more examples like this because it's proven and you can do this. Yeah. This is the way this was done. This was prefabricated in modular wood frames, which were filled near the site from two guys in like 2 weeks. The straw was infilled and it was directly plastered, as you can see. There's a lime plaster outside, and it was erected very fast this way. So, and it is around 2,000 square meters. So it's not a tiny building. So, and with 5 stories. Yeah, and it was made with straw bales, as you can maybe see behind me, directly from the field without any further additional ingredients like flame retardants or something. So because we have all this space in Verden where this center is, and we have a former military area from the British Army. So we have a tank service hall where we can assemble the modules to build this house. And directly after 2014, when this house was finished, we directly did further education and showed people all around the world how to make this happen. And what you see here is students that are assembling these elements. Mock-ups for workshops, but you can easily imagine that you can build with these. and they are putting on clay plaster, which is also fully circular. You can directly reuse this basically all over again. And my job is it's a very rewarding one in these workshops, because you can see easily in these pictures that people are happy doing this, especially the younger ones, but not just the younger ones. For some people like teachers or whatever, they really see a new horizon when we show these techniques and materials, because the quality and sense is immediately clear when you work with this. So yeah, by the way, a full disclosure here, we are ESF funded and funded by by our Ministry for Environment. So we are pretty much independent, and also the Bauwende is also industry independent. So I do not sell straw or anything. I'm just convinced on a scientific basis. So yeah, this was why this is basically why I'm here, because the guys from the conference saw this on Twitter and invited me. I wrote straw is a durable Passivhaus insulation wall, an agricultural residue, and almost half of it is carbon. Yeah. And students ask all the time, because we are the Center for Sustainable Construction, what is the best building material? What is the best insulation material? And I can only say this is a very easy answer. The best building material is the one that does not need to be manufactured. And straw is that way, because straw is a product of food production, and it is easily available, abundant, and yeah, well, it's just there. So, and why is this insulating? Well, air is an insulator, obviously, and you have these large openings in straw, so you can drink something out of a glass or something. But also the wall, when you look at it from the microscope, there are very tiny air gaps. Yeah, so. So this is a very important site. I think this is you should definitely check it out under this material pyramid. The link is on the right side. We see that at the foundation of this material pyramid, and this is about greenhouse warming potential of materials, you see that there's a negative value to it. And straw is 128.2 kilogram per cubic meter, cubic meter, and that is actually the climate relief that this does. And you see that wood fiber is even better. It is 173.1. This is not, yeah, this is better obviously, but this is why this is a more dense material, therefore it's heavier per cubic meter. And this is not the whole truth. These are good materials, don't get me wrong, but you always have to look at least at two values, and in this case, primary energy input. And you can imagine that if a tractor is taking this from the field, there's a lower primary energy input than with wood, where you have to allow processing. But this is still definitely on the right side. So just some quickly, you don't have, you can have this later. I provided links for all of this. Some important numbers about straw, where we have 85 to 115 kilo per cubic meter. This is an important one. This is the preferred raw density of a construction grade straw bale in the construction. So this is the ballpark where we want to go, and where we have all the desired where this just works, yeah, where this is resilient, and we have all this, yeah. So the measurements are typically for a small bale, and there are different bales, but this is the one you see behind me. is typically 36 centimeters by 48 centimeters. But you have to measure. These are not standardized, basically. So then we have a U value from such a bale with a 36 centimeter bale. This is the wall thickness. So you have the Passivhaus criterion. So then you have at least 10% compression inside of the compartment, inside the construction for a quality build. And then you have a lambda value, of course, which is okay, which is not great compared to petrochemical materials, but still okay. And you can see this in the European technical file. So I don't want to disappoint you, but this is basically what we are doing now. We are going up with the things we that should actually go down. And yeah, we in construction, we are a major part of this. And 11%, that is the percentage. In 2018, the manufacturing of building accounted for 11% of global energy and process-related greenhouse gas emissions. And that is quite something. And not many people actually spoke about this the last years in the recent list. So we have to. And yeah, what can we do? An interesting study from Francesco Pitao. He asked himself, what if the European building stock was renovated with different materials? Because 75% of the EU buildings are not fit for climate, basically, have to be renovated. And then he did dynamic life cycle analysis for this, and he looked, will this actually relieve the climate, what we do, over a 200-year time frame. And you can clearly see that EPS is actually from the material side is actually an emitter. It's just an emission. It can't go down because it is actually fossil material. Yeah. So, but even timber is not. I mark this maybe. So timber is very late when it actually becomes negative, and this is what we want. We want emissions out of we want CO2 out of the atmosphere, and this is because trees take a long time to grow back to maturity. And we see that there are other options, and this is hemp, this blue green thing, and this is, yeah, this is, at least it's no emission, let's put it that way. On the important time frame, this is this blue line here. It's 2050. So we need a solution for now, basically, and not in 150 years. And there is straw down there. And it goes immediately down because it grows back after 1 year. So he said that straw showed the most promising potential, being the only one to remove 3% of the CO2 equivalents emitted from all sectors in 2015, and this is quite a lot. Just to 2015, it goes obviously it expands the negative emissions later on, and this is not bashing for wood. We obviously, as you can see with the NZMB, this is also a timber house, mass timber house. You obviously need wood, but this is not actually that beneficial to us at the moment. It is because it replaces material, okay, but this is in this kind of study, it's clearly not contributing in the moment where it matters. And to be honest, I want these 3%. I'm sure we cannot do any all houses with straw, but we can do many. So, and yeah, we have to ask ourselves, what is actually the building we want. We want to build with our budget that is declining. So I would say these are the types of buildings that are actually viable to build new in the moment, besides renovation, because this is a social housing with 26 dwellings over eight stories, and it's pretty efficient from the area it occupies. And it's actually very simple, but not in a bad way. It's very simply built, and like that. There's this CLT structure, and then you have these boxes. Straw is built in, and these boxes are with a permeable board of some kind, like a board, and then they add these vented facade, and this is just roof tiles. I think this is very this is a very good system. It actually is a primary energy heavy tile, obviously, but it protects the mass inside. So this will work a long time without maintenance, and this is a good idea. You can do this with wood as well on the outside, but yeah, this will actually be still a carbon negative thing. So this is our architect from the NZNB, and this is one of the straw pioneers in Germany. He built many houses. Actually, you can't build at the moment more than 3 stories with straw, even though the NZNB is 5 stories, because this was a prototype. The legislative is actually too slow at the moment to adapt. But he's doing it anyway. He's doing 40 dwellings in 4 stories in the same technique as the NZNB. And this is the Baugruppe. Genau. But the straw is obviously also for renovation. And we all have these buildings around the world, like sports hall, school, etc., like concrete buildings, highly inefficient. And of course, you can renovate these, retrofit these with straw beds. There, I provided links on the right. This is Act Echo EU. There's a free course, and some slides are from there. This is a hint that you really should do these courses. They're great. So yeah, why not build schools? I mean, the next generation, they should this should be a role model, right? Schools should be a role model for the next generation, definitely. And in France, they have built many. And look at this website. This is great stuff in France. They are far leading in Europe with this. So yeah, this is France as well, and this is the oldest modern straw house in Europe, and this is easily 100 years old by now. As you can see, this is from 1921. This journal, and this is a pretty modern attempt. You see these ladder type studs there. And this house is still standing. And imagine if this is the Bauhaus area, right? So imagine if Bauhaus was this. Imagine the world now, from an emission standpoint. And yeah, this house is still standing. And my colleague actually, through her journeywoman years, that's perfectly fine. It's now the home of the French Strawbell Building Association. So speaking of old houses, this is in France as well. This is in Paris, and this is straw. This is a straw retrofit. And tell me later, what is your first impression? Do you think of fire or something? Does it belong in Paris? Should this be there? Tell me. This is another retrofit in Germany this time. This is a very interesting system. They have these consoles, this straw building anchor, Strohbauanker. And with a cross-line laser, you just screw them on the facade and have these window boxes. and so on. And then you straw beds like you see here, even on the roof, like you cover the whole house with this. And you see all the super special tools that you need for straw building. Like this is basically garden tools, like a mower and hedge cutter, you know. So, and this is how it looks after the wrapping. And this is the whole area. This is on a brownfield site, a former brewery, and they developed this with straw. Go to this website. These guys are really cool. This is another retrofit. And look at the right side down. This is a very common house in Germany, and they basically look like before, I think. Not from the inside. I think this is a night and day difference from the comfort, as you can imagine. So this is a funny picture. I think this looks great, and I show this in workshops all the time when I teach wrapping, because this looks a little fuzzy. This is my house. I wrapped this in straw. See this, it will look like low tech, low performance maybe or so. But yeah, but look at the difference when it's finished. This is not my house, no? But this looks really cool. And people are convinced when I say this, when I show this picture. So for more, please Fred. I presented a lot of examples worldwide. And if you think this is too good to be true, I also see downsides of straw building. Fred, I also linked there. So my internet connection is stable. Hear me still? Yeah, but a common question here, but do we have enough straw? And I say, yes, we have. And this is a study for Europe, and everywhere at the moment we have enough straw, no problem. So there are two basic techniques to show: prefab and infill. So prefabrication and infill on site. This is prefabrication, and this is endgame fabrication from EcoCoco. And well, this looks stunning, right? This is a pre-braced. You order this house and it ships, and you can assemble this with I think with a very little skill set. You can directly plaster this and so on. I think this is not the future. This is now. So again, a reminder, please see the link on the right side, the Echo course, where you can learn all this stuff for free. Yeah, but you don't have to order this. You can do this, which we show basically at home. This is our workshop situation. Everyone, I think, can, with a little skill, can screw together such a frame and Azure. And I provided some numbers earlier for density and so on. And if you have the right straw beds and so on, you can calculate the combined straw bed length that needs to fit there, and then you can put this in basically. So, like so, it's just this operation, and you need to look at the measurement from the straw beds when it's like 2 by 26 centimeters, and you make the compartment a little smaller, like 95 or 94 centimeters inside. So, and the last step for prefabrication is where you attack the last 4 straw beds at once, and this is the 10% pressure needed compression to it. And it's really simple. You use these funnel boards called flutchies because it moves much easier with them, and then you are ready to plaster basically, and or whatever. Yeah, this is the other variant. This is the classic method, basically in Germany. This is when the house is already built and it's like a skeleton, you can see through. Then you build in the straw bale. You make the infill from the straw with the straw bales, and you can use I would suggest, or you can use lorry straps or whatever you think of. You need this pressure of 10% more, and well, then you and do a few more steps, and then you can plaster this. And you can see here that these battens, these are triangular shaped, and they hold the straw bales in. Build these in on both sides, and you can also do this with these insulation material, and you need to do this so that the belts don't come out, because it's not that they fall out because they're so loose inside, out because there's so much pressure on them. So this is how it looks finished then. This is dressed when you have these battens in, then you will need to use a tool to dress the belts that they can be plastered evenly. And yeah, you see on the ceiling there's a air tightness detail. You will have to plaster this in the floor too. Yeah, and this is how it looks. Then you have several layers of plaster, and then it's ready for living. This is another early method. This is basically the first method of a straw bale house. This is load bearing Nebraska. This was first done in Nebraska in the Civil War in America when the press was developed rightly after. And yeah, you can just stack, but you have to do this with much denser belts, and you have to end tension these belts between the ring beam. You do this with straps. So these are not just stacked and there's air in between or so. This is not the case. This is really hard. So, and this slide shows you that there are not many worries about thermal bridging. You can see the link down there, and this is just an example of how well developed this and scientifically proven and written down all of this is. This is ready to go. So quality control, yeah, all the time you need to keep this dry, obviously, because it's a natural material and it doesn't want to be wet to, yeah. So you want to make sure that it is harvested in a good way. So usually it is. And then you need to store it and transport it and infill. And also you have to make sure that through your design, it also is dry for a long time. Let's say pipes or shower, there can be water ingress. So yes, you have to plan with this. And also you check your belts with can use your nose and your hands. If you feel not the right pressure with your hands, then something is wrong. You need to stuff it. Or if it smells bad, it is bad. It is that easy. Yeah, and German guidelines. These are important key takeaways. This is not just for German builds. These are our quality criteria in Germany, and beyond 85 kilo per meter, straw bale is class E. So it's like it's flammable like wood. Let's put it that way. So a normal construction grade straw bale will be flammable like wood. This is a good news, right? So with 8 millimeter clay plaster on both sides, it will reach B. So this is more, and it can go up to F90. This is the German thing. This will be fire resistant to 90 minutes. Yeah, the lambda value obviously a stock orientation that is going through the thermal attacks here, like so. Yeah, and not I cannot. But when I take the straw this way, I can blast through, you know, and this way it's harder. So the lambda is better versus the fiber. Okay, so this is important. So we don't use the belts flat because that's exactly the problem there, that you can blow through. Yeah, so we have the is always visible with our type of building. And yeah, wheat and rye are particularly well suited, whereas oat must be reviewed unsuitable. So basically you can use all straw, but some are better than others. Let's put it that way. Stud width is 1 meter max, because in Germany we can't do load bearing of the hassle. So this is not load bearing, and we need 10% compression in frame. Obviously, gapless and settlement proof because we will have dew point issues, and this is something we don't want. And airtight and windtight because we want high performance buildings, and it should smell good, as I said. And a clean site is a happy site. So this drawbell beyond 85 kilo per cubic meter is class E, but loose straw is not. So this is a fire hazard, and it should be cleaned every day on the site. So resilience with classic timber construction rules, which it is not much different to timber. You need a large head and high boots. So keep it out of the water. And new rules are warm coat, obviously, because we need performance, and plan future water damage. So here you can see some links later on. You can do courses. Please do the ACT Echo course, and maybe we see each other in a workshop. And now ask me anything, please.
Thank you, Michael.
Hi, Michael. Can you hear us?
Yes.
Yeah, perfect. This seems almost too good to be true. So, I guess many questions from the audience in the room. Podem falar em português, nós traduzimos, se tiverem vergonha, sem problema.
Aqui, por favor.
Okay. So, okay. So, Michael, we have a question from the audience. The question is how it reacts to water when it's constructed. Will it, if it gets wet, it will get ruined? Do you always need to protect it with plaster or the coats that you showed us? Or can it be a natural appearance in the facade?
So it's protected through the construction because it doesn't want to be wet. It won't stay that way in that format or quality when it gets wet. So this is basically a dry material when it is harvested. Not unlike wood, because wood is harvested as a living tree. Yeah, but straw is not. Straw is basically dead when it's on the field, and it's dry. And this is the quality that the farmers strive for, because this for grain, and this is our food. We are reliant on this food system, and they can do it. They have, so we get usually we get dry, really dry straw beds, and they should stay that way. These are around 18% humidity, and this is a very hygroscopic material, and this is no problem. We can do it. We can do it as we do it with timber as well. You have to protect this, in my opinion, with clay, which fits perfectly. As you can see in my room here, this is a retrofit. You can see the old rafters, the tree rafters, and you can see where the window is. There's a straw bale wall. And this is plastered with clay, and this really fits because the clay is also a very hygroscopic material, and it will attack the humidity first. Let's put it that way, and it will it's basically an insurance policy for biomaterials, and yeah, and it if it gets wet through steam, yeah, through humidity, it can dry out, but it should not get wet, like really wet.
Yeah, we always need to protect it from the outside, right? Just to be clear, you also always need a protective coat on the exterior wall so the rain doesn't get it. That's it.
Yeah,
okay,
but there's no compromise. I talked about resilience with classic wood construction rules. There you need a roof and so on, and like not that you can basically build everything with it, but be careful because it is a biomaterial, and we want to build houses that last for generations. We can't renovate them all the time because people afterwards don't have the carbon budget. Keep that in mind.
Yeah. Actually, that was a question we had. You have a perspective of long-term life of the material? Because yesterday we had Lynn talking us about bamboo and how it only lasts maybe 5 years before it rottens with fungi and all that. So is there this kind of problem with straw?
No, actually, they found in pyramids in Egypt, they found straw inside there or buried somewhere, and it was still good. It was not moldy or something. It looked like before. And I live in a very old house. This is from 1724, and I found in renovation I found a straw in there, like really old, like say 100 years. And this still looks good. I can easily build with this. This is very strong. And it really, if you protect this from the elements, it stays that way. It is that simple. You can look at the Nebraska style load-bearing houses in America. You can look this up on Wikipedia on through straw building.
The
These
links,
houses are still occupied.
Maybe you can send us the links after, and we'll share it with
Yes.
everyone, because there were a lot of information and open source information.
Yeah.
So
Micro.
Hi, thank you.
I don't hear you.
Okay, you can talk.
So my question is, how are people receiving?
I still can't hear you.
maybe she'll tell us the question and then we repeat it. It will be easier, maybe.
How are people receiving construction in straw? Because in Portuguese culture, we tell our kids the story of the three little pigs, and somehow the story tells
Hence
the
bad
kids
for the
that's
pig.
not bad. That's bad.
Yeah.
To construct in straw, the better way to construct is in bricks. So how are the people feeling about living in a house that is built in straw?
Yeah, so I think the question is it easy to convince the future owners that straw is a nice, durable, resistant material that wouldn't just go away with with the weather?
The question is, do people really need to know what this house is made of? Do
But
people really care
they may
at the
find out.
moment what they live in?
Normally need. They want to know.
And I almost guarantee you that that no one is running out of a straw house. I mean, we're not talking about a hut here or something. We are talking about if you build with the smallest straw bale, which is the one behind me, this is a 36 centimeter wall, will have a passive house quality. This is a night and day difference to your usual house that is even the ones that are newly built here, these stone houses. It feels warmer. The acoustics are better. It smells better with clay. Obviously, the air quality is better. It's like a low quality, like a low tech climate AC, you know, and so on. The benefits are way beyond the criticism that can of cultural reasons, because maybe we have this they all have maybe this cult stories in mind from the Three Little Pigs or so, which is completely stupid. But yeah, you can't blow a straw house away. This is so dense and strong. Yeah, everyone that comes to us, and there's many people come to us to the center. Most people are convinced, like 99%. And actually, people come to us, and they really afterwards they really want to go, run and build.
Do you think the young people are more interested in this kind of materials?
Please again, please.
Do you think the young guys are more interested in this kind of materials, in building with this kind of materials?
Yeah. Do you think young generations will look at this as easily as a future of construction, or is it, you know, there's no difference between, there's no generation gap here?
I don't think there's a generation gap. I don't think there's a strong bias with wood or natural products, because people have bad experiences with like garden sheds and so on. They're rotting away, and they think this is similar. Yeah, but there's this generation bias maybe, and but for younger people, I think this is really starting now. I think this is so people, and we have in Germany we have Architects for Future. They are really seeing the potential there, and I mean, this is scientifically sound, and when you look at the data, this is just convincing. I mean, this is durable, and this is not so flammable as you would think, and it makes great houses. And it's actually a way to build to still be able to build new houses actually.
Maybe you
Because
could
it's
talk about the
basically-
fire question. You showed us that image in Paris. It was quite impressive, no? A lot of straw in that facade. So, is it safe? You know.
Well, it's almost when it's dressed, it's like you would you have the same worries with the timber there? This is the question. So it's basically the same. It doesn't burn that good. We also make after workshop we make some after workshop fun sometimes, and burn some straw in a fixture with compression, and it's really boring.
Yeah, well, you didn't show it, but there's a video online where you have a burner burning the bale straw, and it's really impressive how long it takes for the straw to burn. So maybe we can move back to the audience. Any questions in the room? No.
Se calhar faço a pergunta para vocês.
Okay.
Mas acho que já está a funcionar o microfone.
Está a funcionar?
Sim.
Sim.
Michael, can you hear me?
Yes.
Thank you. Regarding the question of the solution of the construction, you refer that we need the wood for the structure, right? So this straw is only for the insulation. And I have another question. You said that we have enough straw to build, but what you are considering about this? Like if everyone would build with straw, it is possible for everyone in the world to build with straw as insulation. It will be possible. It is enough.
Yes, thank you for the question. Yeah, this is a common question, and this is completely out of scope for most people how much straw is actually available. And basically no one is asking, do we have enough fired bricks or concrete also? But with straw, they ask these questions, and it's a good question because we in Germany we have so much straw. If we would do this sustainably, like not taking all of the straw, a sustainable amount, and leave enough for other uses, then we could build 350,000 units per year. So this is the difference in thinking. We need this, and it grows really fast, and you don't have to plant one stock for construction, because this is available from food production. And this is just grain straw. You can do obviously build other stocks from other plants.
Okay, more questions?
It doesn't have to be straw.
Oh, sorry.
Hello. Thank you so much. I have 3 questions. I had more, but you keep answering them. So, first off, what is most attractive for me is this idea that you described, that you can have a house that, if it needs to be demolished, you literally compost it. Because the problem we often face when we try to use natural materials is we are obliged, sometimes by regulation, to impregnate them, either with pesticides or insect killers or fire retardants. So I really want to make sure, because what you said did sound too good to be true. Is this straw really completely untreated and you put it in the wall and you don't impregnate it with anything? That's question 1. Question 2?
Well, yes.
Okay, you can answer first.
I think the answer is yes.
Okay, perfect. Simple enough. The second question is, it's also interesting that straw already, like you said, contains carbon. So by putting it in a wall, we sequester carbon. That's not going back outside. I realized I have no idea what is actually happening to straw now. Like, there's so much of it. What do we do with it? What happens to it if we don't build with it? That's the question, really.
Yeah, we have there are uses for straw, but these are short-term uses, like animal bedding. Actually, and on this, and most of it actually remains on the field because there's no use for the. There some countries are burning this, and this is a very bad idea because it smokes horribly. It's very high pollution and obviously, and yeah, also there are no like concurring competing uses for this that are really long term. Like you can make maybe your jeans or paper or something with this, or even OSB boards. Okay, this is also long-term use, but not as long as wall as a wall material. And yeah, I hope that answers your question.
No, I think they get the mic.
It does. And the third question is, it makes a lot of sense to see this built in the countryside, where you do not really have any space issues. And seeing a wall that is 60 to 70 centimeters thick, for someone that needs to design things in a city, makes us quite nervous. So, you know, we often try to, at least in Tokyo, for example, the people are really trying to build buildings with 10 centimeter thick walls. Of course, it doesn't work, but there is pressure for efficient use of space. So I'm wondering if this ever comes up, especially when you work in urban projects, or if there is any regulation update that kind of discounts that extra use of space.
Well, good question. There are, of course, products, yeah, with straw, smaller, like drywall and so on. And yeah, that's an issue. Obviously, when I look at Berlin, for example, you can't do every facade with this in a retrofit, obviously. We have a certain built environment that is built wrong, you can say. And these are not easily retrofitted with biomaterial because it was built in the wrong way, basically. So 36 centimeters, which is in effect, we are talking about a 40-centimeter wall if we are serious with plaster and so on. And this is actually when you see what kind of building we need to build at the moment. And all buildings that are newly built, in my opinion, should at least be around Tiefhaus niveau. So we are talking about like 40 to 50-centimeter walls. So I think this is nowadays no real showstopper. And there are so many cities that are not Tokyo. Let's put it that way.
So one question there. So just a moment. Yeah.
Yes, Michael. Hello. Can you please tell me if you want to pass some kind of structures in the inside of the exterior wall in straw, how can you do it? You know, if you want to pass some plumbing or something of the kind.
Okay. Yeah, you want basically zero risks strategy there, because it should not be wet in this application, and maybe you have something, you will use something else. You will, and in this place you will make a cutout, and you will maybe even a fossil product, for example. But you can lay directly like pipes and so on. You can slit a bale and with a chainsaw, for example, and you can put clay plaster inside, and then have the pipe work. And like for heating, a wall heat, you can do this, no problem. But is this safe when there's water through? Will the next in 20, 30 years, when the next occupants will be there, will maybe through the wall and hit at the pipe? This is a question you should ask yourself. Maybe we advise you to do this for resilience reasons, to move this pipework into the inner walls. But it is possible. It is possible, like in any other. You have the same problematic in a timber house.
Yeah, I think it was clear in our presentation that this is a very specific system that will require a very specific process in the design, so you can adjust the shape to the system. So we have an online question, maybe.
From Ivan Jimenez. Have you applied in commercial use or other kind of different of houses?
Yes. Actually, the NZMB, this is one of the best office buildings, I say, in Germany, because it's like super eco and a passive house. And well, and there are also, I'm from Eastern Germany, basically, and there were even stables and so on built with straw beds. And this is storage areas and so on. Why not? This is available. You can not only build with these small beds you've seen behind me, big beds. And if you're in somewhere in the outskirts, you can do a large hall, maybe load bearing with very 250 kilo per cubic meter, like really dense beds. You can stack them up and sure.
Okay, thank you.
Perfect. More questions? No?
No?
Yeah, Michael, we need...
say,
yeah.
If you want to try it out, which is a good idea, you have seen that you did see that it doesn't take much, but plan your house around the straw bale, not the other way around.
Yeah.
What kind of straw bales you have, and then make friends with this with the farmers if you have good straw beds, and then go for it. Don't plan this the other way around, because it will require a lot of work if the timber work doesn't fit to the straw bed.
Yeah, perfect. So, Michael, we have to close because we are getting almost in the next speaker time. So thank you very much for being with us, for being available from Germany, and to share this amazing material with everyone here and at home. I guess everyone is pretty much amazed how this is possible. It's almost too good to be true. So, Michael, thank you for your time, and we hope to see you soon.
Thank you,
Maybe there.
Michael.
Thank you. Bye bye.